Okay, so this one is going to be really easy and quick. The topic is magnetic energy. Okay, so it says, how do you imagine finding the first magnet came about? Okay, the story is that, and you don't have to write this down, but that more than 2,000 years ago, the Greeks living in a part of Turkey called Magnesia discovered an unusual rock. What they noticed is that as they walked through the rocks, the little nails that held their shoes together would stick to the rocks and be pulled out of their shoes. They also noticed that if they hung it from a string, the same piece of the rock would always point in the same direction. They called this magnetic energy, naming it after Magnesia, where they came from. Okay, so magnets have two ends where their effects are the strongest, and we call them the poles. There's a north pole and a south pole. The most common or most basic kind of magnet is a straight bar magnet, and then the second most common is the horseshoe magnet. You can see both of them in the pictures. You do want to write this stuff down. Okay, so what happens to the poles if you cut a magnet in half? So if I cut them in half, do I get a north that's all by itself and a south all by itself? When you come in, be able to tell me, how would you test this out? Like if I gave you a magnet, how could you test to see what would happen? Okay, it says if like poles are brought close, meaning a north and a north, or a south and a south, there's a force of repulsion, so they're pushing away. And every kid who's played with magnets has felt that before, that invisible pushing in the middle. If we bring a north and a south together, then they stick together. There's the force of attraction. Okay, magnetic poles always have pairs. So if I do cut a magnet in half, I'm just going to have two magnets now. I cannot separate them. I can never get north by itself. I can never get south by itself. Scientists do look for monopoles. They do look to see if they somehow explain how the history of the universe, as far as how it was formed, came about, but they've never been discovered. It says if you could see the magnetic field, what shape would it take? We're going to actually do an experiment where you can see the magnetic field. Alright, so the magnetic field is the region where the magnetic forces act. You know, eventually you get so far away from the magnet it doesn't work anymore. So it extends from one pole of the magnet to the other. It comes out of the north and goes into the south. If I had a bar magnet, this is what the magnetic field looks like. If I had a horseshoe magnet, like this one on the right, this is what it would look like. I would write this in my notes and I would draw these two pictures with the magnetic field in my notes as well. Ferromagnetic materials. This is a vocabulary word you should know. It just means strongly attracted to magnets or can be made into a magnet easily. The number one example would be an iron nail. In class, I'm going to show you how to turn a regular paper clip into a magnet. The easier something becomes magnetized, the shorter the time is it stays magnetic. And that's because if you look at this picture over here, so this top picture would be the inside, if we could see the atoms, okay, of the paper clip, and they're all jumbled up. Well, if I were to strike it or hit it up against a magnet several times, maybe just 10 times in the same direction, I'd create this bottom picture right here where all of the norths are lined up. That makes it magnetic. So now my paper clip is a little magnetic. I can pick up iron filings with it. But because it became a magnet so easily, all I really need to do is drop it and it jumbles back up again like this top picture and it's no longer magnetic. Okay, so we'll do that in class. The magnetic domain is the region where all the atoms are lined up, and in this picture we can see I separated them with these red lines. So we have 1 here, 2, 3, 4, 5, 6, 7, 8 different domains where they're all lined up. Okay, the best strongest magnet is going to have all of them lined up together. Up in this top picture right here, you can see there's 1, 2, 3, 4 magnetic domains. It says demagnetizing an object. You just need to drop it or strike it very hard or heat it up, and that's not always going to be true, but if it became a magnet very easily, that's what you would do. Magnetism is defined as the force of attraction or repulsion of magnetic material due to the arrangement of the atoms. Specifically, we're looking at the electrons. Okay, William Gilbert is the first person to suggest that the Earth is a magnet. It has its own true north, right? And it has a south pole. It says that they've reversed themselves, though, every 500,000 years, and we know this by looking at the magma. The iron pieces in the magma show us. So right here, this is like the North Pole geographically, but slightly down below it, running through Greenland, would be the magnetic north. Okay, so when you go outside and your compass points to the north, it's actually pointing to the magnetic north, not the geographic north. It says in molten rocks, magnetic particles line up, leaving a permanent record. So you're only writing what I highlighted, okay? And then I would draw the Earth with the magnetic field going around it. You should notice, though, that there are two areas here that are not really protected. What are they being protected from? The sun gives off radiation, just like a bomb going off, and it's a lot of radiation. And this deflects it. It actually protects us so that that radiation doesn't get in. If it does get in, we end up with the auroras. So if the sun's radiation gets through the magnetic field, we see the northern or southern lights, or the aurora borealis, also called the Van Allen radiation belt. So it goes by 3 different names. Let me say that one more time. They can be called auroras, the northern or southern lights, or the Van Allen radiation belts. It's just named after the person that discovered them. All right. Those are just a couple of review questions, just some things that you should have gotten from this. The notes are really short. The labs will be fun. We'll go right through this very quickly. This should be an easy unit. All right, see you guys next class. Bye.